After understanding the slopes of the isoquants of the indifference map of Cobb-Douglas production function, we shall now focus on the average, marginal and total product curves for the Cobb-Douglas production function in the short run. And short run has a certain feature that doesn't allow all of the factors of production to change. Here V1 is that factor of production, for instance capital, that we assume will not change during the short run. So in this situation the output will be a function of these two variables. However, V1 variable will be considered as constant for this short run. When we consider this, V1 is temporarily considered as a constant, and we can write them together, that is A and the V1 term, because both of them are considered as constants. When we do this, we can write one constant instead of two, that is the result of this couple of constant terms getting multiplied will give us another constant, the symbol for which can be B instead of A into V1. So B is a suitable notation for this constant, which is the product of these two terms. Finally, we can write this short run production function like this. So secondly, we can learn about the shape of this curve from this situation, that is this functional form where V1 is not present because it is considered as a constant and it is merged in the term B. So Q is dependent upon the variable V2 and not the variable V1 because of the short run. And when we make the diagram of the total product curve in the short run, it will be having a positive slope because the rate of change of it with respect to V2 is positive, because when we invest more in V2, output will increase, but this increase will be decreasing in nature, that is diminishing returns will hold, because V2, when we use it for the second differentiation, the second order derivative of Q is negative. So Q increases but with the decreasing rate with respect to V2. Mathematically speaking, it is verified with the value of B, because we know that the value of B is a fraction between 0 and 1, and when we have this here, the value of beta, when we take its derivative, it appears here in the coefficient place, and since it's less than 1, for example 0.5, it is going to half the value of the Q. So it means that the more we use it for the second derivative, again B will come here and beta will come here and it will become beta square here, and this beta square will be even smaller than the beta because it is less than 1. So the term will reduce as we calculate more and more, and this will show the diminishing returns to V2. The diagrams of these two or three phenomena will look like this. Total product curve, we have already seen it. We haven't seen MP and AP derivation. We will see it right after this. Short run average product curve, it looks like this, because in this process we will take the quotient of the production function with the variable input, that is V2, and when we divide it simply by simplifying it, we can get this form which shows the average product curve, and it is equal to this term. In the same way, we can also find out the short run marginal product curve, and for that we consider the variable factor, which is V2, and we differentiate with respect to it. The short run production function is now being differentiated with respect to the variable input, that is V2, and it is easy to calculate the derivative. B will come out as a coefficient, and we will focus on this term, and we will apply the power rule of differentiation, which will give us this result, and this result is now considered as the short run marginal product curve. So these two diagrams will be plotted here as average product and marginal product, we can consider some values of v2, and this will allow us to come up with various values of AP. In the same way, we can start v2 with 0, 1, 2, 3, and we can develop the marginal product curve. And when we do this, the answer will give us this kind of graph, that is, the schedule will culminate into this sort of graph. So this is about the short run analysis of the Cobb-Douglas production function related to its total, average, marginal product curves. Thank you.